Okay, thank you everyone for coming. I notice it's the July meeting of the ATA, Melbourne EV branch. Tonight we're going to talk a bit about laptop batteries and using them, testing them, where to get them from, how to use them in a home battery system on those. So the technology that we're using for the laptop cells is very similar to what we've been doing with e-bikes. So I've been building e-bike batteries for 4 or 5 years on those from reconditioned cells as well as from new cells as well. So this pretty much followed on. It's much the same technology. It's a bit larger than the e-bikes, then smaller than what we put in a car. So it pretty much fits in the middle of those. But we'll be showing a bit tonight about how we do that. Let's start off with some EV news first of all. I thought this one was interesting when it came up. Japan now has more electric charging chargers than petrol stations on those. That'd be nice to see that in Australia. That's certainly not happening here. But it's at 40,000 charge stations that we have across Japan. Not all those are fast charge. They have a CHAdeMO network, which is included in that 40,000. But that's level 2 chargers and that as well. They've certainly got the country covered on those. So bring the charging infrastructure in and then the cars will come. Has anyone else got any news that they wanted to talk about? Any projects in the pipeline or? So which company was that producing hydrogen car? Toyota? Oh yeah, yep. So Toyota's, I think, is it the Mirai or MA? Yeah, their hydrogen car. I've heard that they're putting into California some hydrogen recharge stations, and they hope to sell a few cars in California. Yep. So there's quite a few of them in Japan, is there? That the Toyotas. Okay, well, that's interesting here. So there's another form of alternative vehicle. I notice both the hydrogen cars are actually electric. They use a fuel cell. Yeah, a fuel cell from the hydrogen power source. Any other news? Any projects in that going on at the moment to talk about? Okay, well, we might get started then. Making home storage batteries using laptop batteries that I'm going to cover tonight. So the first thing you need to make your battery is use laptop batteries on those, and for a home storage battery you're going to need quite a few. You might need 50, 80, 100 laptop batteries that you then need to disassemble. But these are like some of the sources, and those are where you're likely to find some of these batteries. Battery recyclers, people like Battery World, for instance, on those. They will sometimes give batteries out of their recycling program on those if you convince them. Sometimes they will, sometimes they won't. Computer repairers on those, they often get laptop batteries as well. They'll have computers that they're, that are decommissioning, whatever, repairs that never went through. They often get laptop batteries coming through, the repairers. You'll see them come up on eBay and Gumtree quite often as well. People will try and sell or use laptop batteries because they know that now people are starting to look for them. And the prices there on those, well, you'd only really want to pay a couple of dollars on those for each laptop pack. You know, if they're asking more than $5 or $10 on those, they're really asking too much. And you'll get about six cells out of each laptop battery. Industry sources. There's a lot of industry sources that use lithium-ion batteries in their portable equipment. You know, they'll have battery-operated equipment, and those which requires a power source. And most of these, they're all using lithium-ion now. Nickel metal hydride was used for quite a while in a lot of industrial equipment, and lead acid, I suppose, is used as well, which are not really suitable for this. On those, unless you've got the large flooded lead acid batteries, but not the small ones that go into the alarm systems. So with a bit of thought, you might come up with industry sources there, and if you're the only person that's tackled them, well then you might be likely to get some of their batteries. So a little bit of lateral thinking there will help. And then just the general recyclers, the ones like Sims Metals, and the people who are actually doing the recycling. Those, if you can interrupt their waste stream and manage to get some batteries from them, they have large quantities of them. So there's some of the sources you could look at for finding your batteries. Next job, removing all the cells and that out of the battery. So when opening the laptop batteries, I find the weakest part of the battery is the connection, the actual power connection, and that on the case. Like, that's the weakest part of the case in the laptop battery. So if you can crack the battery where the power connection is, and then work your way to both ends from the center, from where the power connection is, you can quite often get the case open without damaging the cells inside. If you're putting a screwdriver in through the case and trying to come in at the ends of it, you can quite often damage the cell, because the cells come right up to the ends and that of the battery packs. So breaking it open where the circuit board is, or the power connection, is the best place to start, and then work around the cell and that to do it. Laptop batteries actually come in several voltages, which people may not realize. But the most common one is the 4.2 volt laptop batteries. On those, this one's a Samsung number here. Samsung, it's a 2.6 ampere hour, 2600 milliampere hour cell, a very common one. The 4.2 volt ones are the most common ones that you'll come across, and those in laptops, and all the brands in that make them. But in the past few years, they've released also laptop cells that are 4.35 volt charging. They have a different electrolyte in them, and you'll find they're also high capacity. They're generally 2.8 to 3.2 ampere hour on those. So you really want to classify which batteries and that you've got. If you put the 4.35 volt batteries into a 4.2 volt pack on those, you won't have any problems or issues in that with that. You'll just get a lower capacity on those than if they were charged to their full voltage. They have an electrolyte in the higher voltage battery that's able to, electrolyte's able to stand a higher charging voltage. And then you need a charging or tester on those for testing them all as well. This is a box that I've made up. I've brought it along here, and after we're finished, I'm quite happy to show some people. We'll show it working and everything with it. But you need something for testing, and that's your cells, and that because maybe a half to a third of the cells that you're going to get are going to come out below specs, and you probably wouldn't want to put them into your home battery. Some of the batteries that have gone to 0 volts may not be usable at all on those. They're damaged through a chemical reaction and not usable. But the way that I use this charging unit here, I've got a small charging section here with a meter. So I place the battery on that first and see what voltage is actually in the battery when it comes out of the laptop. And if it's 2.2 volts or more, I know that that battery is going to be fine to put in for charging. But if it's less than 2.2 volts, I may need to what I call reform the battery on those because it's been left to go too flat. So this is my basic testing first. And if I've got my cells over 2.2 volts, I then just start placing them into the sockets, and that up through here. This charger will take up to 32 batteries. And one thing I didn't mention before, when I'm opening laptop cells, it's quite often easier. You can charge them in pairs. You'll find in laptops they're quite often in pairs within the pack. So if they are in pairs, you can leave them in pairs, or you can break them into single cells if you want to. Both methods work fine. Because when you have a pair of batteries, when they're in parallel in pairs like that, if one's damaged, the other one will too, because they both had the same use, the same life on those. If they've been over discharged down to 0 volts, well, both of them will be damaged, rather than one will be fine and one okay. So they can be handled in pairs or in single cells. So they then go into this charger. This is a balanced charger that will then charge them up. And those, I charge my cells to 4 volts, and that's what I do for testing. So that's just a standard that I've set. With 4 volts, the battery is 3/4 charged, and that's sufficient to test it. You don't need to charge it to full voltage and that to test it using the method I do. So that's just a simple box and that I've made to do that. So this is the unit here, and we'll show you a bit through it later on those, but that's something that I've built in that to do this testing. And then once you've tested all your cells on those, you then have to assemble the battery. What's commonly used for assembling these cells is there are plastic holders that are available to do this. They come in triples like that and also in singles. And they have lugs on the side and they actually clip together. It's like putting together a Lego set. So you can put together, you can start from 3 cells and go right up to as many as you want, and that in each block. So these are commonly used for that. Good safe way in that to do it because they're separated in that by the cells. Another common one we use, this is actually used for e-bikes. This is a battery carrier for e-bikes. You open it up, it's a top and a bottom, and then the cells go in the center, and then you tab weld them. But this will hold, it's designed for a 14S e-bike battery, but it'll hold 1, 2, 3, 4, 5. It'll hold about 80 cells, and that is a pack. So these are available too. This box that I've got here is about $15, and same for something like this, $12, and that from China through AliExpress. So that's the safest way in that to assemble them and that into the packs. Because the next thing that you're going to require, once the pack is assembled, is a battery management system. And these 2 pages that I'm showing you now just give you an idea of how we would wire up a home battery system like that. The battery is here. This is actually 13 blocks. So 13 of these cells in series. So you make your 13 wired in series, forms the battery for 48 volts. And then there's a balance sense wire that goes from each block to the BMS board. The BMS board is the brains of it all. It monitors each group of cells, makes sure that they're not below 3 volts or not over 4.2 volts. And if the batteries go outside that voltage range, it shuts the whole system down on those. So this is a wiring system, and that you use for a home battery. And the BMS board, this board here is not expensive on those. I'll just go back to the other slide and give you some prices. But this BMS board is really only designed for 10 amps and that of use. So what we do is we use it to switch a solid state relay at the top, and that relay is rated at 120 amps. So the BMS board is controlling the relays on those. So you can draw 100 amps out of this home battery through your hybrid inverter on those, and it'll function fine on those because the BMS board has been boosted with solid state relays. And this relay here is for charging. It's the charge relay. The control comes in through here, and it's controlled by the charge port on the BMS board. The power output board connection here goes up to this one at the top, the relay at the top, which is the main output control relay on those that powers the unit. But if it's wired that way, you then have a 48 volt battery that's capable of running 100 amps continuously. So the actual parts in that are used in that BMS board up through here, it's a 13S 48 volt BMS board, common one. They're about $20 on that from China. And then the power relay, this is the solid state relay that's used for that. It has the control input here and the switching section at the top. So that relay is worth $9, $10, $12 from some of the suppliers, so about to say $10 each. So those actual parts there, they're not expensive and they're quite readily available. So, and that's the wiring diagram through here. Other things that have included in it, of course, nice big fuse. You should always put a fuse in everything that you build. On those, the 5AG fuses is the large glass fuses on those, and we put in a 100 amp fuse. And then have a look at a case on those. How are you going to case it and where you're going to install it and that as well. So the battery it's dangerous if it gets knocked or shorted or anything done with it. So it really needs to be mounted, enclosed, cased, and that in a safe way on those because it's your house. So you want to have it safe in those. So you have to think about how you're going to mount your battery, where you're going to put it on those. And quite interesting. This guy here, Kenneth, he's from New Zealand. On those, he built his box on those, similar to a similar style that you may have seen before, and put his name on the front because he built it. So there's his battery, home storage battery. Now with the home storage battery, you're going to need an inverter. You're going to need the correct inverter for your solar system and that to run it. And I've been talking about 48 volt home storage batteries, which is the standard in the industry. You find that most of them are 48 volt on those. So you now need a hybrid inverter, or you need an inverter that's going to match your battery system and make it all work. So they come in two main types. There's two types of inverters. The hybrid inverter is the one that we're seeing going into most places now. It's a smart inverter which controls the power from the solar panel going into the house, decides when to charge the battery, which is obviously during the day, but there's programming and sensors and that work with that, and when the sun's shining as well helps. So you've got your house control, your battery control, and then when to put power into the grid. And those, so yeah, that's in the industry is called a hybrid inverter. And here's a couple of examples of manufacturers. SMA, Sunny Boy, on those, a well-known brand. Their model Smart Energy is a hybrid inverter. It'll work with a 48 volt battery. And SolarX on those are selling in Australia hybrid inverters, and those designed for a battery system as well. And there are lots of others and that on the market as well. The Chinese companies, the South Korean companies, and that they're all making them. There are a lot of them coming out of Asia. Then you have another type of inverter on those, which when I was looking up on a solar page, they weren't recommending this type of inverter. I was going through some of the solar sites. This one only controls the charge and discharge of the battery on those. It doesn't control how much power is going into the grid, or it doesn't control what's coming to the output from the solar panel. So it's a simpler type of inverter. The batteries can be 48 volts, or it could be a high voltage type on those. Some of the solar systems are actually using a high voltage battery, which connects directly to the DC of the panel on those with a higher voltage battery. But the 48 volt battery is the standard one in the system. And so Sunny Boy storage on those. This one's a battery-only inverter, and they've quoted this particular inverter is compatible with the Tesla Powerwall. So on their website, they say this is one of the inverters you can use with the Tesla Powerwall on those because it's a battery storage type inverter. And then there are other brands of that as well, Selectronic, SB Pro, and other brands and that I found when I did my research on those who also make the battery type inverter.
Well, what voltage is the Tesla Powerwall run at?
I'm not sure. It's over 200 volts. It's probably around the 300 volt area on those. It's not quoted there.
As far as we know, it's a low voltage battery, but then a DC-DC converter bumping up to whatever the solar input is. So it'll be high voltage when it goes into the inverter. Okay.
Paul, I just have a question about the SP Pro. I have one of those installed at home. It operates from solar panels, and it also charges batteries and regulates export. So I was wondering why you haven't got that as a hybrid inverter in the top section rather than the battery-only inverter.
Okay, I would say so. From the research that I did from the sites and that I was listed, it was listed as a battery-only battery inverter on those. So is that an error then? Yeah, probably from where I've researched those. I've gone into a couple of the sites and quoting solar installations on those, and that's what they recommended. So some of the other research I did was like with the Tesla Powerwall on those. Choice magazine did a test on the Tesla Powerwall, and it was a minimum of $13,000 to install a Tesla Powerwall, because it would also require a special inverter and that as well. Can't be retrofitted onto an existing system. You have to change the inverter at the same time as fitting the Powerwall. But of course, that doesn't apply to a new installation on those. If it's a new installation, then you install the correct inverter and those and that for the Powerwall. But it's a difficult one to retrofit. And then this was a bibliography there, so there's research then done on some of the different places that I've looked at. So if people want to go through and have a look at some of the research that I've done on those, especially in building Powerwall setup. Yahoo Garcia, he's in California. He's built the electric Samba, which is a Volkswagen electric car, and also a Powerwall. UK DIY Powerwall, it's another just small site with a lot of information on those about a Powerwall that then he's built. This particular guy here, Paul Kennett from New Zealand, who I had some of the pictures in the example on those. Very, very detailed site, a lot of information about how he's tested batteries, how he's different construction methods that he's done for building his home battery. He also has, with Thingy Universe, he has 3D files on how to build these battery holders on those, which you could 3D print on those, your own battery holders. And the battery holders that he designed were capable of taking pairs, like twins, that came out of the laptop. So that's why I was mentioning that you can keep them as twins and that in laptops. And then these are the two links on AliExpress for the BMS board and the solid state relay. So that was it what I was going to show for you tonight. I really wanted to make it simple on those and with sufficient detail for you to go through and see how it could be constructed on those, the wiring diagram and those, the testing and that of the cells. On those, I have a test unit here on those that I keep at home that I use regularly. I'm using this unit also for testing power tool cells as well. That goes into e-bike construction. But laptop cells would be suitable for a home storage battery. So so I have this available, and if people want to have some cells tested on those, I'm quite happy for them to catch up with me on those, and then go through, and then they can go through and testing and that of cells. So there was that part. We've pretty much gone through that. So what I wanted to do afterwards on those is with this unit here, and those we can set it up, maybe set it up in the other room, in the side here. And I've got cells here that I brought with me, and I can show you how we test them, how we condition the cells, and go through a little bit of what to do, how to form batteries, form batteries here that we're not sure are going to be working or not. So I can go through that with the battery tester and give you an idea of how we test some of these cells. Yeah, we'll answer a few questions now, sure.
Would you like to tell us a little bit about the electronics box that's sitting on there?
Which electronics box?
That little silver thing with the buttons on it.
Yes, this is a radio-controlled charger, a typical charger that's used for charging the batteries in radio-controlled planes on those, so it's a programmable charger. It is capable of charging 4 blocks of batteries at once. So this is 1 block, 2, 3, 4. So it handles all those batteries together as a block. So it charges 4 blocks at once. This little unit here also has an internal resistance meter in it as well. So when I want to test a battery for its internal resistance on those, you need a good quality battery holder so that you get a 0 connection on the contacts. This type of battery holder is not sufficient on those for testing internal resistance. So we can test internal resistance in that of each cell. and those, and I can then compare them with others of the same brand on those, and then grade my cells as good, used, or definitely not worth using. You know, that's the common things and that's what you look for. This little tester here is also able of testing the capacity of the batteries as well. It's a capacity tester. That particular test is much slower on those. It can take you a couple of hours and that to test 4 cells. If you put 1 cell in each block and then do a capacity test. So that's sort of testing I don't do to actually measure the capacity of each individual battery. The internal resistance tests that I've mentioned here gives me an accurate image of how that battery is compared with a new battery on those, how much wear and that it has. I have questions? Yep.
Yeah. If you use just a series configuration of battery as you showed in your diagram, what capacity battery does that produce roughly?
It depends upon the capacity of each block on those. So the 48-volt battery, which is 13 in series. So depending on how many cells you have in parallel, we could start to go through some of the maths and that there. For a home battery system, you probably want 3 kilowatts as a minimum. A 7 kilowatt home battery system, and that would be good. So then divide 7 kilowatts by 48 volts, and that will give you the number of ampere hours and that of the battery. So ampere hours is what we're looking at on those, and ampere hours is just multiple cells in parallel, you know, a block made up out of multiple cells.
And you didn't talk at all about how you weld the tabs on batteries.
No, I didn't on that, which I do. I have a tab welder and I assemble them in tabs. One thing I wanted to show you was, oh yeah, I suppose this one shows it here. If you break the cells up into singles and that like this, on those you'll have to tab weld all of your cells and that together. But if you leave the batteries in pairs and that in doubles like that, they're already pre-tabbed. There's a tab there connecting the 2 cells and that together. They've already welded it onto the batteries and that for you. So that's another advantage of leaving them in pairs, because then you can actually assemble the blocks together in pairs and you can solder onto the existing tabs. So you can use a bus bar or a copper contact, and you can then solder onto and that to each tab. So yeah, so there's 2 ways of doing it. You don't have to have a tab welder. A tab welder will cost you between $250 and $300 on those to buy a tab welder. But if they're in pairs and they're pre-tabbed, they can be soldered. Now, any other questions? The process of battery
The process for battery conditioning, please.
Process of the battery conditioning, okay. And that up through here, I'll get a battery out of a laptop cell, and it'll be a single or it'll be a pair. With my particular unit, the way that I do it is I'll put it in the battery form position first on those here, and then the voltage will come up on the meter on those as to what voltage that battery is. And those, if it's over 2.5 volts, on those the battery has sufficient charge to be able to charge directly. On those it's in good condition. If it's below 2.5 volts, on those, you're right, I'll then have to put the battery through a forming process on those to make sure that the battery and that is okay. I'm going to demonstrate that next door and that with the actual unit. I've bought in some batteries here that haven't been formed, and I know some of them are faulty, so I can show that. What we do is we put the current maybe in the low position on those, and then start watching the voltage, and it'll start to charge the battery at 50, 80, 90 milliamps. It'll put a low current through the battery, and we'll watch the battery voltage rise. And it may start off at half a volt, and then it may rise slowly to 1 volt over a couple of minutes, and then go to 1.5 volts over several more minutes. And then if the battery is faulty, has a problem with it, its voltage will not rise any higher. It'll go to 1.5 volts and then it'll stop and won't rise any higher, even though we're running a small current into it. Or it may go to 2 volts and then stop and not go any higher on those. So that's where the voltmeter up through here, and those comes in handy, so you can watch the voltage level rise. And the unit will try and reform the cell. But if the cell is damaged, its voltage will not rise anymore. And sometimes they even reverse. They go to 2 volts and then they start going backwards and then drop down to 1.5, and you realise that that battery has been damaged, chemically damaged, by allowing it to run flat. So this is some of the things that I've noticed and that I found when I've been checking these cells. If you have a damaged cell and you try and charge it up to 3 or 4 volts, you know, you put enough current through it, like you then put it into a normal charger and start charging it in an amp or 2, it's at a high current. What will happen is it'll start to get hot. It'll heat up on those because it has a high internal leakage. And this is quite dangerous. The battery could possibly explode. It'll overheat. On those, you're creating a dangerous situation. So that's why I have the battery forming unit here, for forming the batteries, and I can adjust the current flowing through the forming section on there to reform a battery. So if I have a battery that's flat and it's half a volt, I'll know within half an hour whether it'll reform or not on those, whether it's usable or not. Yes?
Paul, batteries have a life cycle, number of charges, discharges. In a laptop battery, you would never know how many cycles it's already been through, and therefore, even though the cell tests okay, it might be halfway through its useful lifetime. How do you cope with that?
How we cope with that? There's a couple of ways that we cope with that as well. Yes, you're right, the battery has a cycle life, depending upon what voltage it's been charged to, and this battery also has a calendar life as well on those, so they actually degrade 2 to 5% per year on those. So both of those issues come in place, the cycle life and the calendar life of the battery. So if we've got a battery through, we've gone through the reforming process and done that, and it's come up to 4 volts. What I'll then do is I'll test its internal resistance, and that will tell me how degraded the battery is. Because the internal resistance of the cell on those as you test it is a good reliable way of giving you the degradation of that battery. So if its internal resistance is supposed to be, say, 25 milliohms, and it comes up more than 20% high, on those I consider it not worth using. So 20% is, that's another 3. So if it was 18 milliohms or 19 milliohms or higher, then the 15 milliohm reading that I'm supposed to get off it, then I'd consider that cell degraded, not worth using. And then, so I use internal resistance and that to test the quality of the cell and how much it's degraded through use. Yeah.
Just if you're building a decent sized battery and you're building 48 volt batteries, with you doing battery management, I take it you duplicate all the battery management, so you're only running cells in series. When you use, because cells, if you're recovering them, they might have variations. So if you parallel them all up, it's not ideal.
Well, let's talk about that then. Yeah, okay. With paralleling cells, the way the battery management system works is it handles each battery as a block, a block of cells in parallel on those. So that's this is a symbol of a single cell or a single battery. So that's 3.7 volts. It could be 40 ampere hour, depending on how many cells are in parallel. It could be 80 ampere hour on those, depending upon how many cells are in parallel. So with lithium-ion batteries, as you notice within the batteries that are constructed, it's fine to parallel cells. You can parallel as many cells as you want, and you can also parallel different brands and different types of cells. As long as they're all the 4.2 or the 4.35 volt cells, they have to be the same charge voltage type cells, depending upon the 2 main types of laptop batteries that you buy. So you can get these cells and you can parallel them. You can put different brands, parallel them and that with no problem at all. So what can happen, say this particular block here has got a lot of weak cells in it on those, and it's poor. So instead of being 80 ampere hour, it's 70 ampere hour on those. The battery management system will actually check that this voltage is low across this block, and it'll shut the battery down. So your battery will only go maybe to 3/4 flat, and then it'll shut down, and instead of getting the full capacity out of the battery. So I've just mentioned, say this block here is 70 ampere hour instead of 80 ampere hour. So what you do is you then add a few more cells on the end. On those, you can put, you can use these tab joiners here. I mean, these bands. You can clip a few more clips on the other side, and you can actually add onto that bank of cells. And you add sufficient cells to make it up to 80 ampere hour on those. And that's fine to do that on those. And then your battery then rebalances on those. Everything is correct, and you'll go back to the full capacity of the battery. So a battery that's constructed this way, is modular like this, it can actually be serviced on that through its life. On those, if you find that your battery capacity is dropping, on those, you can actually measure each individual block on those and find the weakest block, and then add cells to that particular block on those, and then its performance will come back up. But of course, you're getting degradation with age and with charge cycles, so the whole battery is going to progressively reduce in capacity on those through its use. But 300 charge cycles is actually to 80% capacity on those, so we're quoting there that 80% capacity is considered the end of life on those. But in a solar system, on those, you could run the battery right down to 50% of its original new capacity, and it'll still function fine. It's just that it won't store as much energy as it did when it's new. And those, so that's where repurposing cells can go into a solar system, and that for it, because you can actually still use them even though they're past the life on those within the first use that it was. In a laptop battery on those, you have your laptop battery, and you find that after 2 years or so, it won't charge properly anymore, and you're only getting half an hour out of your laptop battery instead of the 4 hours, and that when it was new. What quite likely is happening in the battery is the management board inside it is actually shutting it down early. On those, you'll find that a lot of those cells aren't degraded on those within the laptop battery. On those, the battery management boards that they put in the laptop cells are very good on those, and they do any error and those that comes up, they'll shut it down. So it's not as if that half-hour battery, it's not as if those cells are only now at quarter what they were when new. They will vary. Actually, some will come up quite good, and there may be a few that are deteriorated. And then you can find that in testing, with each block. Yes?
Just a quick one. When you're saying you're paralleling the cells together, are you checking similar voltages or anything? Because if you've got one down at 2.7 volts and the other one up at 4.2, you're going to get a...
Yes, I am. The way that I do that is I charge all my batteries to 4 volts.
But if you got when you're charging them there at that point, are you?
That's when I charge them first before I assemble them into parallel packs.
So you're just charging ones. You're saying that charger does 4 sort of charging cells individually. Have you got 4 paralleled or 8 paralleled there at that stage when you're charging them, or are you just doing one at a time then?
Okay. With this particular one where they're paralleled in here and those within the battery packs, there's actually current limiting circuits behind each individual battery here. So even though you may look at it and think that they're all in parallel, they're not. On those, there's current limiting resistors actually behind each pack to limit the current if you have cells that are not even. So I can place a cell on there that's at 2.5 volts or a cell that's at 4.15 volts, put them in parallel quite safely. And then they will actually balance against each other as they're charging. So yeah, I've taken that into account with this particular design, yeah.
Just from experience, in terms of the cells you've recovered from laptop batteries, 50% are good, 25% are good. Can you give us a sort of a feeling from your findings?
It's about, from what I've found, say from Battery World, for instance, say getting them from their recycle program, on those, there'd be about 60% of them come up usable on those, within 20% of original manufacturer specs. So that's the sort of the results that I'm getting. With Battery World and that, I get those sort of results. From some of the industry sources that I get my batteries from, I'm up around 95 to 98% on those because they decommission them out of industry before there. So that one's quite good on those, but battery world are about 60%. I find the cells are worth using. Probably the computer root repair would probably be similar. Yes, if they knew how to open them up and use them for another purpose, they possibly could. But you're right, the battery's not functioning in their laptop anymore on those. So yes, on those. Yes, it's probably a function of the battery management systems that are used within these laptop cells. On those, they seem to be designed to shut the battery down and to cause problems. They don't seem to be very well designed. Well, probably I can then put that back to an e-bike type use. So I haven't put, I can't give you an experience in solar on those. So in an e-bike use, you're looking at another 2 to 3 years in that of use, of recondition of these well-tested cells. So typically another 2 or 3 years. Those. Yeah, that's an interesting point. Yeah, I do. Yeah, I do match the batteries on those. So say if I'm building a block like this, I know that remember I said there's 13 in series. On those makes you 48-volt batteries. So I'll start to group my cells into lots of 13s and those, and I will put the same type of cells in each block. What I'm saying is the same variation of cells in each block. So if I've got 13 Sony cells, I'll put 1 in each block. If I've got 13 Samsung cells, I'll then add 13 more to each block. So in other words, I'm trying to make each block the same as its neighbour. I know, so yeah, that's how I do match them. So you can, as you can see, you can mix the cells within the same block, but the 13 blocks should all be similar.
Well, I'm not too sure whether you said the 10P13S was for electric bike or for the Powerwall.
Right.
But it seems to me that that at the 1C rate would give you about 1 kilowatt, which would probably be a bit light on for a Powerwall.
Yeah, I think 10P is not enough. You need more than 10 in parallel on those and that to do that. On those, so a 48-volt home battery on those has 13 blocks in series. And then your ampere hour is how many cells you've got in parallel on those. So 10 in parallel and an average of 1.5 ampere hour each. You're right, that's only 15 ampere hour. That's too small for a home battery. You'll need more than 10 in parallel for each.
Paul, do you have any experience using LiPo packs? Because I know the newer laptop batteries since like 2010 are mostly LiPo.
Oh, yeah.
Have you come across them or built any packs with them?
Yes, I have on those. And the LiPo packs, when we had the original 18650 cells like these, they're all the standard size on those. 18650 is a 18650, it's a common size. There is a couple of minor variations that you see. And then they make a wider one called a 26650. That's a bit thicker, but it's used only in power tools and some other. So it was great. They were all standardized and everything was fine. And then when they changed to LiPo, there are all sorts of sizes. There's no standards in pouch cells, I should say, or LiPos or pouch cells. There's no standards in them. So they're virtually impossible to use in something like this because every pouch pack is different on those, different shape, different size. It's a logistic nightmare trying to put them all together on those and even just to get them to fit when you've got some small ones, some big ones. No, actually, when I get the pouch cell packs, I usually put them back in the recycle bin. I don't even open them. The Apple computers use pouch cells, and there are a couple of others. Some of the newer HPs have changed to pouch cell as well. But no, you're right, I avoid the pouch cells. They're a total pain. There's no standardization with them, so it's very difficult to come up with any quality control or any standardization that'll work. So luckily, even in a lot of the newer laptops, a lot of them are still using 18650s, but the pouch cells are taking over because they're smaller, they're higher density, and they're a bit lighter. Okay, any other questions? Because I'd like to set this up in the other room and I've got cells here I can put in it, and I can show you some how it forms cells and how it works. So sometimes even just in the working on those, it can be better than just theoretical and explaining that on the board. So let's go in the other room on those, and if we want to, we can have a cup of coffee or whatever, but let's set this up and I'll show you a bit of the work that we do. Thank you.